Good morning to one and all. Today we are going to speak about the topic polymorphism and what are the types of the polymorphism in this. First we can see what is polymorphism. It will be the process of representing one form in multiple forms is known as polymorphism. Here one form represents original form or original methods resides in the base class and multiple form represent overridden method which resides in the derived class. That is, poly means what it means, it is many. Poly means poly, the word means many, and morphs means many forms. So, what they are telling is we have the same original form, but representation is in a different manner. Same original form, but in same base classes, but the derived classes will be of overridden different methods. So, in representing one form with multiple forms is known as an polymorphism. We can explain it of detailed. This is a simple example. Say like shapes. Shapes we are going to use the method as a draw. So same method it's going to be used in every shapes a draw method. So the method same. So shape is a one form. We are representing that shapes in multiple forms. So first shape will be the base classes and these triangle, rectangle, circle will be in the derived classes. These are the multiple forms with a different behavior. Shape can be of triangle, rectangle, circle. So in triangle, if we give the three sides, the shape will be the triangle. If we give the four sides, it will be the rectangle shape. If we give the radius or diameter, it will draw a circle. So giving one form, and this is the easy representation of the polymorphism. So poly means is a many, morphs means it is of a different forms, different format. Another example is this is a real life example. What it means is, suppose if you are in the classroom, that time you behave like a student. When you are in market at that time, you behave like a customer. When you are at home, at that time you behave like a son or daughter. Here one person have different behavior. So this will be the well understood. So as if you are a student, if you are a student in class or colleges or in schools, in classrooms, you will behave like a student definitely. But when you go to the market or any further purchase, you will behave like as a customer. Suppose same person when you go home with your parents, you will behave like a son or daughter, not like a customer or a student. For parents, we are only a son or being a daughter. So, same one person have different behavior. This is a well-suited example for the example of the polymorphism. There is many types of the polymorphism. Two types are there in polymorphism: compile time polymorphism and runtime polymorphism. This compile time polymorphism is further divided into function overloading, operator overloading, and runtime polymorphism will be of virtual function. Now we can see more about the compile time, or it can be a static and different names. So here, these types of polymorphism. Static polymorphism is also known as an early binding and compile time polymorphism. So the memory will be allocated only in the compile time. So this polymorphism is acts only during the compile time. What will be the compile time? It is a static. What is the meaning of the static? It will be the stubborn time. So in compile time, what we are doing, we are compiling the programs and we are finding the errors. This type of timing is used in the compile time. It is also known as a static. Dynamic. Dynamic means it will be changing. What is going to be changing during that time? We will give the different types of input and different types of output we are delivering here. But in compile time, what is the program? Same program is compiled. If it is an error free, it goes to the next stage. If it is an error, it is going to be identify what are the errors in the compile. So that it means it is static, it does not change, but in dynamic depends upon the input, many changes in the output. So dynamic polymorphism is also known as a late finding and runtime polymorphism. Dynamic, it is stored in allocated memory is allocated in the runtime. So again, what is in a compile time polymorphism? It may be of the method overloading. That is, whenever same method name is existing multiple times in the same class, that is, same method name means same function name. In one class, different functions can be given. Different functions with the same name we are giving here. That it means whenever same method name or a function name, you can keep it as function name or method name is existing multiple times, not one time. We are giving many function names with the same name in the same class with different number of parameters. Parameters can be different or different order of parameters. Number of parameters means we can declare the parameters integer a comma integer a comma and b c or integer a comma integer b. So number of parameters can be of different and different order of parameters. Order also can be of different forms and different types means data types integer a comma integer b and float a comma float b or it can be of double a comma double b. So different types, the data types also can be of different. This type is known as a method overloading. This can be as a method overloading or function overloading. So in method overloading, what we are giving in same class, different functions are given with the same function name, but parameters can be of different types, different orders, and of different number of parameters. So we can see with a simple example. For example, class addition that performs addition of two numbers. So addition means what we will have thinking of, we can plus, we can add two numbers, or we can, if we are giving strings, we can concat the two strings. So it has a function add, that is be common overloaded two times. So we can see the example. The function add. If we are giving integer x comma integer y, that those integers x and y it gets added. Two numbers are get added and the output is printed. Then a function add with no arguments performed. If we are giving string concatenation, that is, if we are, instead of giving integer, we are giving the string, it concatenates both the string and gives the output. This is an example for method overloading or function overloading. First, header file. We are first creating the class. Class name is addition. So class addition, then public integer add. Add is a function name. What we are giving inside integer x comma integer y. So here we are giving two numbers to add. So we are returning x plus y. So two numbers gets added and we are returning the values. Next, another function we are creating. What is still the function name? Same function name, integer add. So here we are not giving any arguments. So without parameters, we are declaring the function here. Here we are giving, instead of integer, we are giving two string values. String A, one string as an hello and another string B as another string Java point. Now, by using concat string C is equal to A plus B and we are printing the same. So these are the two functions. One function is to add the two numbers. Another function is to concat the two strings with the same function name add. Now in the made function, we are creating the object. To addition object, cout. So by using the object, we are calling the two functions. First function is called by giving the integers 120 and 105. And second, that function method is called by the concatenating the string. Since it's already given as an input, so no need to here. This we can call the functions that we are returning. So output will be, now first function, if it is called, then we are adding the two numbers 120 plus 115 is 225. And if you call the strings, it concatenates and gives the hello and Java point. Next type is an operator overloading. What is an operator overloading? So still now we solved the method of function overloading. Same function in different parameters. The overloader. Here operator overloading. The process of making an operator to exhibit different behavior, different instance is known as an operator overloading. So here what we are doing is an same operator is given and the different behavior and the different instances are given using the operator overloading. So what can be overloaded? What is predefined operators only can be overloaded. So some simple types of the overloading, unary operators. So unary operators will having only single operand, that is unary plus and unary minus unary complement unary. And in binary operators will have two or more operands. So all the binary operation, addition, subtraction, multiplication, division, equal to everything will be having a two or more operands. Now we can see of the examples. So in example, same as an, we are going to use the binary operator. Binary operator. So we will be having two operands and one operators. So here we are creating the class A and declaring the data members as a string, and we are calling the functions A. We are assigning the data members as an x is equal to I, calling as an operator plus operator. This is an operator overloading. Now what we are doing is we are converting the strings void A operator A to the another. Now in string M we are creating an x plus A dot x. So see out the result of addition of the two objects. So what we are doing is we are concatenating the two strings. Or we are concatenating the x values and the string we are concatenating. So in main function we are giving the two string as welcome and the second string as two Java pointers. So A1 plus A2. We are concatenating the two strings. So what will be the output? The result of the addition of the two objects will be the concatenating the two string welcome to the Java pointer. This is an output. Next, we can see about the virtual functions. What is an virtual functions? This is an of the runtime polymorphism. In C++, virtual function is an member function in the base class that you can redefine in the derived class. That is what we are giving in the base class. It can be redefined in the derived class. It is declared using the virtual keyword. It is used to tell the compiler to perform dynamic linkage or late pointing from the functions. Okay. There is a necessity to use the single pointer to refer all the objects of the different ranges. By using the pointer variable, we are going to use in the base classes. So we can create the pointer to the base class and can be referred to the derived class. So whatever we are going to use it in the dynamic classes, that is in derived object, in pointer variable, you should declare in the base classes. Then only we can refer in the derived classes. But when base class pointer contains the address of the derived class object, always executes the base class function. These issues can only be resolved by using the virtual function. So what we are doing is a virtual is a keyword. We are presenting the normal declaration of the function. When the function is made virtual, C++ determines which function is to be invoked at the runtime based on the type of the object pointed to the base class pointer. So this is an virtual functions. So by using the example, we can create virtual. We are using the keyword as function. So what we are doing is declaring the header file. Then class A we are declaring. So in class A, what we are doing is we are initializing x is equal to 5 void display. So we are going to display the x order value. Next, we are creating the class B. Here we are declaring the initializing the y variable. Here we are displaying the y values. After that, in main function, what we are doing A. What is an A? For the class A, we are creating the base class pointer B. So in this example, what we are doing is star A is the base class pointer. The pointer can only access the base class members, but not the members of the derived class. Since in C++ we have permits the base pointer to point any object derived from the base class, it cannot directly access the members of derived class. So we need for the virtual function, we allow the base class pointer to access the member of the periodic class. So after that we are doing here, or then we are displaying the a and the value of x is equal to b as 5.